Okay, so first things first, for sine rule, just a quick review is A over sine of angle A is equal to side B over sine of angle B, which is equal to side C over sine of angle C. Now this, because they are just fractions, can be written as the reciprocal. So this could also be rewritten as sine of A over side A, and then that's equal to sine of B divided by side B, which is equal to sine of C divided by side C. Now this one is a little bit more convenient for this particular case that we're using, just because it takes away one extra step, which makes it go a little bit faster. So I would recommend using that one. Okay, so when we're talking about sine rule, we are talking about triangles that can have more than one side. So for this example, where AB is 10, so this is side AB, and then BC is 7. So they also tell us that CAB is 30 degrees. Now, when this is 30 degrees, this is one potential triangle, but we could also have a triangle where this side is 7 and this becomes point C. So there are two potential triangles that we could have in this one. But sometimes both triangles don't work, and I'll talk a little bit more about what I mean by this. But first of all, let's just go ahead and set up the problem and solve it. So first, we have that the sine of 30 divided by 7 is equal to the sine of ACB divided by 10. And what I can do with this information is then solve for sine of ACB. And I'm going to kind of talk through this a little bit just before I simplify it. So I know that the sine of 30 is 1/2. So 1/2 divided by 7 is 1/14. I'm going to go ahead and multiply both sides by 10. So then I have 10/14. And in order to get ACB by itself, I'm going to take sine inverse. So I have angle ACB is equal to the sine inverse. Again, I just solved this problem of 10/14. Now this is equal to 45.6. Now the first thing you have to remember with these problems is sine. Remember, in your unit circle, sine is positive in the first. Sine is positive in the first quadrant and the second quadrant. And since it's positive in both quadrants, we have to do every problem. So you find the angle, but you also have to do 180 minus the angle as well. So not only could this angle be 45.66, it could also be equal to 180 minus 45.6, which is 134.4 degrees. So these are two potential answers that we might have that work for this triangle. However, we have to do something else to make sure that both of these answers work. We know that the sum of all angles is 180, so you need to make sure that the sum of your known angles is less than 180. And I'll show you what I mean by this, because the known angle that I already have is 30. So I would have to add 30 degrees to this one, and that gives me 75.6, and that one works, so we're good. And then I add 30 to this one, and it's 164.4, and that is less than 180 as well. So both of these triangles are possible. Now in a couple seconds, I'll go over the other types of examples that you might see on Delta Math. But for now, that's it. Just a quick reminder though, we have, just to make sure y'all remember, Jacqueline has 1A, Liz has 1B, Leonard has 1C, Sonia has question 2, and Rohan has question 3. So really quickly, now I will stop the share. and I will do the other type of problems. So the first example I have is where we just have no cases of the triangles. And so in this example, I went ahead and drew it out, but we're going to set up the problem. And we have sine of 31 over 15 is equal to the sine of angle P divided by 63. So I'll go ahead and cross multiply. So we have 63 divided by 15 times the sine of 31 is equal to the sine of P. And when you end up taking the sine inverse, the number comes out to be 2 point something. So when you take the sine inverse of this, your calculator will give you an error. And what it means with this error is you can never take a sine inverse of a number that is greater than 1. You can't do that. So what this means is that with the information they gave us, there is not a triangle that can fulfill those requirements. The other type of problem that could have no case possible is if both potential triangles are eliminated by the 180 rule. And I'll show you what I mean now. With this example, the first thing we do is we set up our problem. We have the sine of 16 degrees being divided by 89 is equal to the sine of angle I divided by 71. So when we set this up, you solve your problem, you end up getting that angle I is equal to 13 degrees when you solve it. Again, you just cross multiply and then take the sine inverse, but you get I is equal to 13. Now, again, remember we have to use our 180 rule, so this could also be equal to 180 minus 13, which is 167. Now, again, before I put in both of these answers to Delta Math, I have to check the 180 rule. So what I'm going to do is add my known angle of 16 to both of these. So when I add 16 to this angle, I end up getting 29 degrees. So this one works. That's great. When I add 16 to this angle, I end up getting 183. Since this is greater than 180, I know that this angle is not possible, so it's not an answer. Now, sometimes you might end up eliminating both answers, and that is okay. It would just be another one where there's no possible case. Okay, so that should be enough to get you going on your Delta Math.